This video is going to cover Chapter 4, Section 1, which is Radian and degree measure. It's our introduction into trigonometry. So, very basic information, some of the parts of the angle. An angle has a terminal side, an initial side, and the vertex where they meet. The initial side leads to the terminal side. So the direction of the arrow tells you what's the difference. The beginning of the arrow would be your initial side, and then the end of the arrow would be the terminal side. Again, where they meet is the vertex. Angle measurements can either be positive or negative. If they are positive, then your initial side is on the x-axis, and you're moving counterclockwise around your circle to your terminal side. If you're talking about a negative angle, then your initial side is still on the x-axis, but the arrow is moving in the direction that is clockwise around your circle. So counterclockwise positive and clockwise negative. There are two ways to measure an angle. One is in degrees and one is in radians. So a radian is the measure of the central angle of a circle that intercepts an arc equal in length to the radius of the circle. So measure of the central angle that intercepts an arc equal in length to the radius, which is telling you that the arc would be the same measure as the radius here. That would be 1 radian. So if you think about this in terms of one whole circle with a radius of 1, and what we know about the measurement around the circle, that's your circumference, which is 2 pi r or pi times diameter. If my radius is 1, then the measure around my whole circle would be 2 times pi. And if we approximate pi to be 3.14, then we're saying this is 2 times 3.14, or 6.28. So 6.28 would be the measure all the way around my circle. Which means if I start here at 0, I come all the way back around at 6.28. So we can use radians instead of pi. So a lot of times you'll see pi like pi over 2 and pi, those are radians, but you can also say things like 1 or 1.2 radians. So the entire circle all the way around is 6.28 radians. So if you're trying to approximate the radians in terms without the pi in it, like where would be an angle that's 2 radians or 3 radians, the easiest thing to do is take your circle, and if all the way around is 6.28, then halfway, this is my 6.28 over here, then halfway would be 3.14. So directly across my circle, this measure here is 3.14, which means a little less than that is 3. Let's say that right here is 3. If I draw a diameter through the circle, then on the other side is 6. And then if I take the arc that goes from 0 to 3 and divide it by thirds, right about here would be 2, right about here would be 1. And then connect those through to the other side of your circle. 2 goes to the other side as 5, 1 goes to the other side as 4. That way you can kind of approximate what your radians are as whole numbers. So that if I was graphing something like 2.5 radians, I would know that my first line would be at 0 here, and my terminal side would be halfway between that 2 and 3. So these are approximations. They don't have to be exact. You don't actually have to measure around the circle. They're just some approximations, but that should give you an idea. So all the way around your circle would be the 6.28, halfway the 3.14, and then judge your the other radians from there. The way you determine radians is theta, which this little symbol here means theta, and we're going to use it a bunch, is equal to the measure of the length of the arc, which is s, divided by the radius. So theta being the angle would be taking the length of the arc here and dividing by whatever the radius is. So let's talk about drawing the angles in standard positions. If you're drawing the angle in standard position, then the 0 line is your x-axis pointed to the right. So always we'd start here. And then if it's positive, we're going around my circle counterclockwise. And if it's negative, we're going around the circle clockwise. So when you think of in terms of a circle that has a radius of 1, all the way around is 6.28, or more specifically or more accurately, 2 pi radians. So all the way around my circle is 2 pi, which means halfway around is going to be pi. Divide that by 2, and you're a quarter of the way around the circle, which is pi over 2. And then halfway between the pi and the 2 pi, 3/4 the way around the circle, is 3 pi over 2. So these are what we call quadrant angles, and those are the first ones you want to learn. 0, pi over 2, pi, and 3 pi over 2. All the way back around would be 2 pi. Example 1 says, draw and label each angle in center position and then state which quadrant the angle lies in. So if I start with my X and Y axis, A says alpha, which is this little symbol here, is 3 pi over 2. Remember, 3 pi over 2 is 3/4 of the way around the circle. So I'd start here with my initial side, and then I'd go around my circle, ending 3/4 of the way around the circle, which is 3 pi over 2. This symbol, which is beta, is asking you to graph 2 pi. So I'd start again, terminal side. This time I'm going all the way around the circle back to 2 pi. So both the initial and the terminal side are the same side. This last one, and this symbol is read as theta. Theta is 7 pi over 4. 7 pi over 4 converted into a mixed number is 1 3/4 pi. So here I know I'm going 1 pi is half my circle. 1 1/2 pi is 3/4 the length of my circle, which means I'm going to go 1/4 past that, midway between the y-axis and the x-axis. And that's going to be 7 pi over 4. So if you're dealing with a fraction and it's not one of your quadrant angles, then you want to look at it in terms of your x and y axis. So if it's bigger than 1 pi, I know I passed the 1 pi. And then you have to ask, is it bigger than 1 1/2 pi? That means I'm going to pass my 1 1/2 mark. If it's smaller than pi, the question is it bigger than half pi? If it goes bigger than half pi, I pass the half pi mark. If it's in between 0 and half pi, then I know it's in that first quadrant. So you want to convert it into a mixed number and then look at it in terms of the 4 quadrants. Again, this would be 1/2 pi or pi over 2. This would be 1 pi or pi, 3 over 2 pi or 1 1/2 pi, and then this is back to 2 pi. Coterminal angles. So an angle that is in standard position that has the same terminal side as another angle is called its coterminal angle. So if I just look back at 2, let's say I'm doing pi over 2 and then 5 pi over 2. If I want to graph pi over 2, I'd start at 0 and I'd go up to the y-axis, which is pi over 2. When you go to graph 5 pi over 2, you want to convert that into a mixed number. So 5 over 2 is 2 1/2 pi. 2 pi tells you you're going all the way around the circle once, and then 1/2 means 1/2 past 2. So these have the same initial and same terminal angle or ray, but one goes around the circle one more time, or one goes around the circle one less time, depending on how you're looking at it. Those are called coterminal angles. If you're given an angle, for example, pi over 2, then you can find its coterminal angle by adding or subtracting 2 pi. So if I wanted to find a positive coterminal angle, I could add 2 pi or 4 pi over 2, and I get 5 pi over 2. If I wanted to find a negative coterminal angle, then I can take pi over 2 and I can subtract 2 pi from it, or 4 pi over 2, and I get negative 3 pi over 2. So negative 3 pi over 2 means I start at 0, And negative 3.5 or 3 pi over 2 is negative 1.5 pi. So negative 1 is here, negative 1.5 is here, and again, same initial and same terminal side. That makes them coterminal. Example 2 says find two positive and negative angles that are coterminal to the given angle. So I want to find two positive and two negative. If you look at A, if I have a negative to start with, I want to add 2 pi until it gets positive. So I'm going to add 2 pi to this. I'm going to convert 2 pi over 1 into 8 pi over 4 so that they have the same denominator. And then combine them, negative 3 pi and 8 pi is positive 5 pi over 4. So that is a positive coterminal angle. If I want an additional positive coterminal angle, then I'm going to take this and I'm going to add 2 pi to it again, or 8 pi over 4. And I get an additional positive angle, which is 13 pi over 4. So that's 2 positive. When I go to get my negative, I'm going to take that negative 3 pi over 4, and this time I'm going to subtract 2 pi, or 8 pi over 4. And I get negative 11 pi over 4. That's the first of my 2 negative coterminal angles. And then I'm going to subtract 8 pi over 4 again, and I get negative 19 pi over 4. So 2 negatives are negative 11 pi over 4, negative 19 pi over 4, and 2 positives are 5 pi over 4 and 13 pi over 4. So this means I should be able to graph each of these and all end up with the same angle. Okay, let's try B. So same thing, 2 positives. I'm going to take 5 pi over 6 and I'm going to add 2 pi to it. 2 pi is the same thing as 12 pi over 6. And I get 17 pi over 6. That's the first positive. Add 12 pi over 6 again. And I get 29 pi over 6. That's the second positive. If I want negative, 5 pi over 6 minus 12 pi over 6. That's negative 7 pi over 6. And then subtract 12 pi over 6 from that. And I get negative 19 pi over 6. So let's just say that when you subtracted, it didn't make it negative. Like your initial angle is so large that even though you subtract 2 pi, it's not negative. That actually is a positive. So if it stays positive, but you've subtracted 2 pi, that's a positive coterminal angle. If it's asking you to find positive and negative angles, you need to make sure that the answers have the signs of what you're looking for. So this is a positive, this is a positive, this is a negative, and this is a negative. Sometimes you have to add 2 pi more than once to get it to be positive, and sometimes you have to subtract 2 pi more than once to get it to be negative. All right, so now we're going to talk about angles and degrees. All the stuff we just talked about was in radians. Now we're switching it over to degrees. In terms of a circle, and hopefully we remember this from geometry, all the way around my circle is 360 degrees. So I start at 0. Halfway around would be 180 because that's half of 360. All the way back around again, we'd be back to 360. Halfway between the 0 and the 180 would be your 90, which is at the top. Again, should make sense. That's a 90-degree angle. And then halfway between the 180 and the 360 is 270 at the bottom. So those are your quadrant angles. Those are the positive ones. If I work my way the other way around, then I have 0 here. Negative 90 would be at the bottom. Negative 180 would be left. Negative 270 would be right. And this would double back around again to negative 360. And then all these individual angles in between, there's a pattern for. It's 30 degrees, then 15 degrees, then 15 degrees, then 30. But we're going to learn that when we start to fill in our unit circle. We talked about how to find the coterminal angles using radians. This is how you find it using degrees. Because 2 pi is the same thing as 360 degrees. If I want to find the coterminal angles in degrees, I add or subtract 360. So converting from degrees to radians. If I'm in degrees and I want to convert to radians, I would take my angle measure, which is in degrees, and multiply it times pi over 180. So something like 30 degrees times pi over 180. I can reduce this by canceling through the zeros, and then 3 goes into 18 6 times. This is pi over 6. Converting from radians to degrees back the other way, I do the angle measurement, which is in radians, and I multiply it times 180 over pi. So if I convert this back, if I took that pi over 6 and multiplied it times 180 over pi, the pi's are going to cancel. 6 goes into 80 30 times, and I'm back to degrees. Another way to write the measure of an angle is using degree, minute, second notation. So degree, minute, second notation is relative to the circle again. It's broken down into 3 parts: degree, minute, and second. So the degree will be in front of the little degree symbol, just like this. The minute would be in front of one single apostrophe symbol, and the second would be 2 tick marks. Think about degree would be out of a circle, 365 degrees. In the minute section, there would be 60 minutes in the circle, just like it would be in an hour. And then seconds, there'd be 3,600, just like there'd be 3,600 seconds in an hour. So we're going to learn how to convert from one to the other. Most of the calculators actually have a button that will do this. If they do not, then when you go from, let's say you're going from degree, minute, second notation into decimal degree, then you'll take your 31 degrees, that would be your whole number. You take your second number, which is the minutes, divide it by 60, and you'll get that decimal, and then add that to the seconds divided by 3,600, because that's how many seconds there are in an hour. And I'll add those all to that 31 degrees. So in this case, if you did 47 over 60 plus 12 over 3,600, you end up with that 787. And then that's the decimal portion of your degree. If you're using the graphing calculator for this, then you will use the little button that says apps, and above that says angle. So if you were to type in 31 for the 31 degrees, and then hit second app, so you get the angle measurements, you'll hit the degrees, and then the second part of it was 47, so you'll type 47, and go back to that same menu, second, apps, and the little single tick mark is right there at 2, hit that, and then the last portion, which was 12, it's actually in a weird spot, so it's not in that angle section, it is directly above your plus symbol, and in mine, it's in green, which means alpha. So I do alpha and the green symbol, and then hit enter, and it will convert it into decimal degree. Some of the other calculators, and I can help you individually, but some of the other calculators have an app, an angle button, and they'll have the individual tick marks there. But this is specifically for most of the graphing calculators. And if you want to convert back, so let's say I had it in decimal degree and I want to get it into degree, minute, second notation, then I can go back up and grab this answer or whatever, is currently there. And then go back to your apps menu, so second, apps. And notice that the fourth one on the list is that arrow DMS. If I just pick that one by either doing the 4 or scrolling down, hitting enter, I hit enter, and it's going to convert it back into the degree, minute, second notation. So sometimes you're going from degree, minute, second to decimal degree, and sometimes you're going from decimal degree to degree, minute, second notation. So just make sure you know how to do both. All right, so example 3 says convert the angle from radians to degrees or vice versa. So you want to look at what's here, determine if it's degrees and radians, degrees or radians, and then convert it. And most of the time, if there's a pi in it, it's going to be a radian, but not necessarily all the time. So the only surefire way to tell the difference between the degree and radian is that degrees has to have a degree symbol. So this is degrees, A is degrees, and so is C. The other two are radians. So for degrees to radians, I'm going to multiply by pi over 180. And we did this one, this 30, we know goes in 6 times. This is pi over 6. When you look at B, we just said this is in radians. So I would multiply times 180 over pi. And again, when we should recognize the pi's cancel and 2 goes into 89 times. Pi over 2 is 90 degrees. That's located at the top of your y-axis. looking at C, 160 times pi over 180. Again, we can cancel through the zeros, and then 16 and 18 are both divisible by 2. This would be 8, this would be 9, and I'd get 8 pi over 9. So on a question like this, you probably would not have a calculator. I wouldn't rely upon it. And you want to keep it exact, so you want to keep it as 8 over 9 and not round that to a decimal. Last one on this slide is 3 pi over 4. So if I multiply this is in radians, so if I multiply it times 180 over pi, the pi's are going to cancel. And then 4 goes into 180, 45 times 3 times 45 is 130. So 135. And then because you want to distinguish the difference between the radians and the pi, please make sure that your answers that are degrees have the degree symbol. Those that do not, don't. All right, complement and supplement. So again, something hopefully you remember from our early ages of geometry. The complement of something is two angles that sum to 90 degrees. So if I want to find the complement to an angle, I would take, and it's in degrees, I would take that angle and subtract it from 90. If I want to find the complement of an angle and it's in radians, I want to subtract it from pi over 2. And supplementary, two angles that are supplementary are angles that sum to 180 degrees. So if I want to find the supplement of an angle and it's in degrees, I want to do 180 minus the angle. And if I want to find it in radians, it's pi minus the angle. Both complements and supplements should be positive. So if you, let's just say it says that there's an angle that's 100 degrees, and you go to find the complement and you do 90 minus 100, you get a negative 10. That is not an answer you can give. So a complement and a supplement has to be positive. If it's bigger than 90, you would say it doesn't have a complement. And if it's bigger than 180, you would say it doesn't have a supplement. All right, example 4. Find, if possible, A, the complement, and B, the supplement of each angle. So for A, this is in radians. So if I was going to find the complement, I would do pi over 2 minus 3 pi over 4. Convert this to 2 pi over 4, and I end up with a negative pi over 4. So I know there's no complement. And that you can actually catch at the beginning and save yourself the work. If what you start with is bigger than a half pi, then there's going to be no complement. But if you don't catch it, do the work and get the answer. If it's negative, rule it out. B is the supplement. So the supplement is pi minus 3 pi over 4. Or 4 pi over 4 minus 3 pi over 4, which is pi over 4. B is now in degrees. So for the complement, I'm going to subtract it from 90. It's not bigger than 90, so I'm going to go ahead and do that. 90 minus 82, which is 8 degrees. That's my complement. And B, 180 minus 92, which is 98 degrees. That's my supplement. The last topic that's discussed in 4.1 is arc length. And again, hopefully it's something you remember from geometry. Arc length is the linear length of the arc, which is kind of like the crust of the pizza, okay, or crust of the pie. If I took a string and put it at one end and then dragged it around there and then I measured it against a ruler, that's going to give me length. So this is not in degrees, this is going to be length. So this could be in inches or centimeters, anything like that. And the formula for it is S equals R times O, or theta. Sometimes I reverse this order so you could call it SOR. It's S is the arc length, theta is your angle, but the catch is it has to be in radians, and then R is your radius. So if you're given the angle, which would be the central angle, this angle here, if you're given that angle and it's already in radians, all you have to do is multiply it times the radius to get the arc length. If you're given that angle and it's in degrees, you have to first convert it into radians and then multiply it times the radius to get the arc length. Example 5 says find the length of the arc. And if you look at number 1, R is 3, theta is 120 degrees. So I know it's S equals theta times the radius, but theta has to be in radians. So 120 times pi over 180. My zeros cancel. And 6 goes into 12 twice, 18 3 times. So theta in radians is 2 pi over 3. Now I just take that and plug it in with the radius. So S equals 2 pi over 3 times 3. And then that's 3 over 1, so these can cancel, and S equals 2 pi. If it had given me units like 3 centimeters, I would put it, 3 inches, that kind of thing. If it doesn't, then it can just be units. 2, now we're given the picture. So this is my central angle here, which is 4 pi over 5. That's going to be in radians already, so this is theta. And then this measurement here is my radius. So I already have everything I need. I just have to multiply it out. Theta, 4 pi over 5 times 7. And then I can't simplify it, cross canceling. So I'm going to say that 4 times 7 is 28 pi over 5. And this time they gave me a unit, so centimeters. All right, now we're just going to reverse the order and depending on what information you're given. This time it says, find the radius of a circle with the given information. So A gives you the length of the arc and theta. If I plug it in, S equals theta times the radius. This time the length of the arc is pi. That means that's S. Theta is 3 pi over 4. And R is what we're missing. So I can do this piece by piece. I can multiply by 4 on both sides. I'd get 4 pi equals 3 pi R. And then I can divide by 3 pi, or divide by 3 and then divide by divide by pi. They're going to cancel here. On the other side, the pi's cancel, and I get just 4/3. I could have also just from this step here multiplied by the reciprocal. So 4 over 3 pi. And I could have canceled it all in one step. Again, this time it didn't give me a unit, so it's just 4/3 units. B, again, gives you S, or your arc length, and theta. So S equals theta times the radius. 24 pi equals 4 pi times the radius. Divide both sides by 4 pi. Cancels here, pi's cancel, and 4 goes into 24 6 times. So 6 units. That's the end of the notes for 4.1. You can use the rest of the time to work on your assignment.
Have fun doing your homework.